Yeah. If you ever end up in court being inquired about a fatality, which involves somehow your software, you should have good argumentation that you did everything to prevent that.
The first talk today will be by Christof, who is sitting there. Möchtest du schon nach vorne kommen? Christof develops software-defined vehicle solution at Aptiv. Am I pronouncing that right? Leads the Rust working group there and is a really senior Rust person who has a lot of good ideas about the ecosystem. I've had the joy of talking to him a lot of times. And is doing a lot of open source software, some games, I think, many more than I do maintain and do contribute. So if you have any questions, go to him.
Okay.
Yeah, so I'm so thrilled to stand here and talk to you about Rust in automotive. I will just skip to the next one. Doesn't work for me.
It doesn't work for me either. Oh, you're changing the brightness on my screen.
Okay. Okay, but in theory it should work. Okay. I started, my first programming language which I learned was assembly. Because it was a long time ago, and then assembly was a natural choice. I also learned BASIC, did my first larger programs, also Warenmanagementsystem, I forgot, Enterprise Resource Planning Systems in BASIC. In 1989 I learned Rust, I learned C. sorry. I learned C, of course that would be totally lie. Then I learned C++. I was quite happy introducing C++ also into automotive, into safety systems. I lobbied towards getting C++ approved for ASIL B, which is the moderate integrity level in 2008. And then a coworker introduced me to a new language, which I should take a look into, because he said I would like it, and that was Rust. So in 2020 I had a lot of time at hand. I learned Rust, and I found that I liked it so much that I don't want to continue with any of the other languages any longer. In 2022, I lobbied for Rust in my company, of course, in 2021. And in 2022, I was lobbying for getting some organizational start on putting Rust into functional safety. So I talked to a lot of people, and then I got back from people working at Society of Automotive Engineers, SAE. You might have heard of one of their standards. For example, they classify the 6 levels of automotive driving, level 0 to 5. And I got co-chair of the Safer Rust working group there. Nearly at the same time, AutoSAR also asked for a person which would help with getting Rust into AutoSAR. So because they knew me from SAE, they asked me. So I got a dual speaker role, basically. The past 1.5 years I spent mostly on WebAssembly systems or standardized interfaces. The next version, which is going to be presented in November this year. This is also overlapping with AutoSAR because I needed a way of combining C++ and Rust. And I found C is not the ideal choice in between, but I was looking for a more high-level interface, and that was perfectly given by WebAssembly interface types, and so this is why I ended up here. I learned Rust on an open source game, which is called Valorant.net, and I do have 2 adult kids which are living actually abroad. So, okay. I should probably not press the button. So, if you think of safety standards, functional safety, you probably are remembering one of the ones on the left side. So the first one, the IEEE one, is the mother standard of all the other ones. This is industry independent. And then there's a specialized industry-dependent standard for all the other ones. And for automotive, it's the ISO 26262. So this is basically an application of this standard to automotive. For aerospace, it's the RTCA D0178C or 332, which is more about object-oriented languages. This one is about the general thing. And of course, it's not only these standards, but it's also coding guidelines. And this is typically MISRA, which is Motor Industry Software Reliability Association. And they are really working towards making software reliable. And of course, there's Computer Emergency Response Team, which is about cybersecurity. And full disclosure, I did not even read the 26262 in full detail. I just read one part out of 12 or 11. And it's many, many details, and it's quite scary. And why would anyone even care? And this is quite easy to tell. If you go to the next slide. Sorry. Yeah. If you ever end up in court being inquired about a fatality, which involves somehow your software, you should have good argumentation that you did everything to prevent that. And so this is a very nice, well-studied case. It happened in 2009. It was quite prominent. It featured quite a lot of press coverage. And Philip Koopman of the Carnegie Mellon industry, he testified on that case. And he also did a very good presentation, and his lecture about this is available online on YouTube. Highly recommended. So this is why. Just disclosure, what actually caused this? There are many theories. It was never finally figured out. Memory corruption was highly likely. They found many, well, not up to highest industry standards code within that system. Stack Overflow was quite high, likely. And they had lots of global variables, so plenty of race conditions. I've been there too, but not with functional safety, so I know what actually this is about. And it was considered sort of state of the art until Rust actually entered that game. Also, they found that some runtime tasks exceeded their slots, and of course, cosmic radiation, something which we do not consider that likely. If you put your software in enough cars, and these cars are driving around enough kilometers, so spending enough time in the environment, suddenly cosmic radiation will actually happen in your cars at least once a week. So it's not likely, but it becomes likely, and so you have to take care of it. Functional safety typically models software development in the V model. Of course, this has a bad reputation due to the waterfall model, which means that you start here, then you spend roughly 2 years just getting the perfect requirements. Then you just make design for another half year, and then you just implement it for 3 years. You test it for half a year, and then after roughly 5 to 7 years, you look whether it still fulfills your requirements, and it doesn't work that well. So that's shortened it, and that is called agile development. But nevertheless, it all starts with you actually make sure you know what you need to do, then you design accordingly, you implement it, which takes a time, then you test it, and then you just check whether the tests really apply. And it's always important that you go this way. You can, of course, shift it a bit to the left, so overlap it a bit, and you always need to make sure that your tests actually check against your requirements. So this is what this V model is about, and how software development is made sure that it's adhering to the standards. So I brought some code from my code at AutoSAR. This one is C++. And a question which I'm often asking myself is this code correct? Probably, it works. But am I sure that the code is correct and that it would not actually, this is a service responder. So actually, you're asking it to just handle your requests. And of course, that could be invoked in parallel from incoming network incoming network packets. So it could run in parallel. Also, when I'm shutting down the system, it could be that maybe I'm getting another network packet at a point where I'm already destroying this data structure. This is not totally obvious, and there's nothing within C++ which would prevent that, aside from just being very sure, being very tedious, documenting your assumptions, and always making sure that your code still lives to your assumptions by hand. Because there's some things you actually can do, but this is considered not bad, state-of-the-art code. You can see here's a mutex. You have to lock it and you have to unlock it, and you have to make sure that everything you access in between is actually covered by that lock, by hand, or by looking closely. And this is why I know the code works, but I would not trust it. I would never want to defend that in code in Curd. So let's go to the next slide, which is why do I consider Rust more suitable for safety development? Because simply it prevents errors at compile time. The compiler and the libraries go to great lengths to prevent any error, to actually make any error prevent compilation. So the compiler will tell you, okay, you did something wrong, it's here, and you immediately get a feedback at compile time, which is quite easy early in the development process. It enforces globally across all of your program that only a single instance is allowed to change a data, or you can share it and access multiple times the same data. And this is enforced by the so-called borrow checker, which is something newcomers to Rust probably hate because it always tells them that something is wrong. Most of the algorithms I learned previously I cannot use with Rust because they simply are too freely using references into memory where you can actually not guarantee that it would be thread safe. Yeah, and Rust has excellent tooling, and I can testify that it's fun to do. It's a bit like solving puzzles. So I looked for a similar code in Rust. This is also from AutoSAR. This is also handling requests from the network. And would I want to testify that in Curd? Probably also not. I also know it works, but it just works. I need to improve it. You can easily tell that it's not ideal by just spotting the word unsafe. There's plenty of unsafe in here. And for this one, it's quite well documented. You just go to the documentation of the into inner unchecked function, and it tells you the following assumptions need to hold true for it to call. In this case, it's careful. This is one of the darkest corners of Rust. If you learn Rust, you will never go there, hopefully. If you ever encounter pin and you're still learning Rust, just go to a different spot. If you encounter unsafe, you should probably rethink what you're doing and look for a different solution. So this is why. And this unsafe just tells me you're actually getting a mutable reference to an object which is pinned in place. So it's not supposed to move away. Don't move it, even if actually the self pointer would enable you to. This is why it's unsafe. You actually need to make sure that whatever that function documents as a precondition, you actually adhere to that one. But yeah, as said, so in comparison to the C++ code, I would be more willing to just testify that this is correct. I would still put more work into it to make it better and more easily argue about. So there's a famous presentation at Rust Nation UK in London last year, and one of the senior developers of Google, Lars Bergström, he actually disclosed a lot of things about using Rust at Google. So he disclosed one of the questions, and that was, how confident are you that your Rust code is correct? And 85% of the people he actually asked about within Google said that they're more confident in the correctness of their Rust code compared to any other code in any other language. And I clearly can understand that. Yeah, this is a massive number. And it's very, it's a good reason for starting Rust. So if we just look for Rust in safety, there is the ANSI guidelines of the French Agence Nationale de Sécurité des Systèmes Informatiques. This one is basically the Bundesamt für Sicherheit in der Informationsindustrie of the French government, and this one gave guidelines for using Rust. This is mostly about cybersecurity. There is the SAE JA 1020. This is the guideline which I developed over the past 3 years, and it's coming soon. It just passed its final vote on acceptance, and it's in pre-publication. Last November, maybe October, the Safety Critical Rust Consortium was founded, and they are working on a large cooperation to get publicly accessible guidelines for Rust written down. Anyone is free to join. You can even join. Anonymously. It's intentionally made so because they don't want to alienate people working in the defense industry, which is an interesting statement. If you need to go for a compiler qualification, which means you're not working in aerospace, because in aerospace you cannot rely on the correctness of the compiler. You have to prove your binary to be correct. In the automotive industry, we can rely on just arguing about the source code, and we need some qualification of the compiler. And there are 3 companies doing that. They are also offering some crate qualification, but it's always an interesting debate on which crates qualify for being actually getting part of that and which crates don't. And there's, I can tell more about that later on. So from the same presentation, it's not only about safety, but we also enhance efficiency. They found that actually compared to C++, Rust is actually twice as effective or efficient. So the same team can do twice as many things as compared to C++. And I perfectly believe that, having used both languages. Yeah, and my personal take is if you add safety guidelines to the mix, which intentionally restricts the amount of parts of C++ you can actually use by a large amount, you cannot no longer use exceptions, you can no longer use dynamic memory in all parts. So it really restricts quite dramatically. And for Rust, it's not that dramatic. And this is why I consider another twofold efficiency increase in safety guide projects. And even hobby projects like Valorant, they enforce the rules on their code because they want to have maintainable code. So the difference in quality between safety qualified code and hobby project code is much smaller in Rust. You can even just take the code from hobby projects and qualify it because the compiler has your back. This is what helps a lot, yeah. So there is some public information and much more non-public information about how Rust is used in the automotive industry. Toyota is a Rust Foundation member. and they have been quite helpful for Rust, for getting Rust into automotive. Emper actually did public presentations about Rust trainings. More than 100 engineers were actually trained on Rust with them. Volvo did the first known, so my first introduction to Rust in safety was actually by Volvo. And VW actually created this project called Samar, which is not yet publicly available. Nevertheless, information about it is publicly available. I can tell more about that as well. And the most interesting one is roughly 6 weeks, I don't recall exactly, ago, the Verband Deutscher Automobilindustrie created or published a memorandum of understanding of working jointly on a safety certifiable open source stack, and the operating system of that one is called SCORE. And this memorandum of understanding is still available. I have some more about that, and also these companies are publicly actually advocating the rules of Rust within automotive. If you just go to the next one, I have from SCORE. In general, C++ should only be used for the existing modules that are taken over or are referenced by the SCORE project. For new features and components we aim to develop in the code, mostly in Rust, as it seems to be more suitable for development compliant to ISO 26262. This is also quite a bold statement, but this is exactly one of the founding statements of SCORE. This is why I'm so excited about that initiative. And if you just go to the next one, last slide, so I hope there's plenty of time for questions as well. Safety is a culture. It's not adhering to some books and doing some checks and whatever. It will not get you to real safety. You have to aim, and you have to question and improve. I know that Toyota commemorates the 911 call of the people which called in from the vehicle which I showed on the second slide each year. And so they really take it seriously, and they are dedicated towards putting Rust into functional safety. And safety is an ongoing process. Everyone is involved. Everyone needs to help. So this is where I would like to end on.
Yeah, very well. Thank you very much, Christof. Now it's time for getting some questions from the audience. So we always start with questions on site with the first one. So let me have a look around. So the moment, yeah, 2 already. But you were first.
Okay, so thank you for the presentation. My question would be about, so you have shown the sources of errors which may or may not exist in Rust in the beginning, like global variables or shared memory or stuff. The issue, what I see with that is that these are only one part of the whole picture. So even a lot of I would say maybe not at the same level as Rust has, but a lot of other languages have also similar features to prevent such errors.
Yes.
So would you think that using Rust would at sometimes give you like a wrong safety, where you see I'm using Rust, so maybe there are some other kind of error with sneak in. Of course, it's not about like something which Rust could use, but just about focusing about these topics which make Rust different or better than others, that you sometimes would then not pay enough attention to the other actual topics where, I don't know, some other errors would maybe happen in the whole, how the program is structured, not in the code itself.
Rust is only one piece of your safety story. And of course, testing is vital to having correct products. Also, a correct design, which is not tied to a specific programming language. It's just that many of the, 70% of the most dangerous errors were found to be prevented by Rust. So it's the memory corruption errors. So it gives you a good lever to just improving your quality, but it's not it's not a catch-all. You need to do more, of course. And of course, there's plenty of languages which are already memory safe. For example, JavaScript, Python, .NET, C#. You can use all of these. Go is also quite memory safe. But Rust is the first language to not pay an additional penalty of a runtime. So it's the first language which gives these guarantees without requiring a garbage collector. And this is why Rust became so widespread so quickly, because it's bringing all the benefits of memory safety without having you to pay for the garbage collector, which might do things you don't want to do, especially in time-critical systems.
Very well. Do we have a question from the online audience?
Haven't got any yet.
Then I would.
I guess I have a question, maybe.
Then go for it. Then we have one online, right?
Do you still write any C++, and do you think you would ever, and if you don't, do you think you will ever in the future, or do you think that you've had a full switch and you're all in on Rust from now on?
Well, full disclosure, my C++ has become a bit rusty. I trusted my C++ much more before I ever learned Rust. Now, after learning Rust, I know what can go wrong and how often it goes wrong. And so I'm still writing C++ because as part of the interaction, so all of AutoSAR Adaptive is written in C++. So to interface with that one, I need to write C++ and really complicated stuff with variadic templates and similar things. I don't enjoy it. The compiler has become much better, but still the Rust compiler is far ahead when it comes to user-friendliness and understanding of error codes. And especially, I think the more recent C++ gets, the less I actually miss. I heard that even introspection got into C++ or will get into C++ 26, maybe 29. This is the one I was waiting for some time, and then I decided, okay, Rust has it, so let's move over. Unfortunately, within functional safety, 2017 is the most recent one which is qualified. So you don't get all the nice things which came later in C++. And in Rust, you get qualified compilers for a compiler which is roughly 3 or 4 versions behind the unstable one. So which means it's times 12 weeks. That means actually it's roughly up to 1 year.
That's pretty fast. Yeah.
That's pretty fast, considering that from unstable development, you actually end up in use for safety critical things with qualification within 1 year.
That's very
and it's
very
a continuing
impressive
process.
Yeah. Very good. I would say regarding the time, we only have like one question left. But there are a lot. Let's go for 2. So, Timo, and then you, my friend.
Yeah, you talked about using Rust is enough, and to already have the compile time checks is very good. But are there any other resources for more the architecture? And can you tell some tips or have some resources I can look at to build a more robust architecture overall?
Yes, formal verification is one of the things which dramatically increases your quality of your code. It also helps with the unsafe ones. There had been an idea for something like Valgrind for checking the unsafe codings. That was called Crab Cake. Unfortunately, that might have been just a PowerPoint. I don't know. Perhaps someone is working on it, but it sounded quite promising.
Okay, I was looking for some Rust code guidelines, something in those directions, because having a full proof of correctness is a lot of time.
Safety Critical Rust Consortium has plenty of good material.
Thank you.
And it's available on GitHub. So.
All right. Next question, Henrik.
Thank you very much for the interesting talk. I'm interested in the lobbying part of it. In my context, I'm often confronted with people saying, yes, they use Fortran 66, but they're really, really careful. How did you react to similar notions, or were you free of that?
Well, yeah. This was my reaction to using C++ in safety critical in 2008. We just have to test carefully and just continue. And it was state of the art. It was the best you can actually do, because C was worse, because C had not enough abstractions, so it was more difficult to get right. You can always do. I have helped too many coworkers debugging C++ for race conditions, for use after free, for all these things. I don't trust that language any longer.
I agree. Okay, then thank you for the nice talk and enjoy the pizza.
Thank you.